Hello, welcome to free fall question number 2. I'm going to demonstrate how to solve this one. Alright, let's get organized. So a rocket rises vertically from rest with an acceleration of 3.2 meters per second until it runs out of fuel at an altitude of 1200 meters. After this point, the acceleration is that of gravity downward. Let's figure out velocity of the rocket when it runs out of fuel, how long it takes to reach this point, maximum altitude, time to reach maximum altitude, velocity striking Earth, and total time. So this is a pretty much standard, all the stuff kind of type of problem. So why don't we analyze it? So what we have is our rocket. There we go, there's our rocket. Little rocket things, and it's got a little geek and smoke there we go. So it starts off from rest. So when I hear that word, starts off from rest, there we go. That's automatically a piece of information and a number that we know already. It has an acceleration, speeding up, as you might imagine. We know this distance is 1200 meters, which is going through the acceleration until it runs out of fuel. So what this means is after this point, it's just gravity. So in other words, right here, right when it stops fueling, it's going to keep its motion. So it's actually keep going. As you might imagine, if you threw a ball up in the air, it's going to go up and then it's going to come back down like this. Just because the fuel has stopped doesn't mean the whole thing stops. It just means it's no longer being pushed, so it's just going to be under the influence of gravity, which is what it's meant by that problem. So what we're trying to figure out is a few things. So first of all, it wants to know, part A, the velocity when it runs out of fuel. So right here, what's our final velocity? So if you notice, this is basically our change in y. Acceleration, initial, we need final velocity. So as you can kind of imagine, I like this equation because it has everything we need in terms of solving for final velocity. Let me plug in the numbers for you so you can see how this is set up. So the rocket initially starts at rest. Its acceleration during that time is 3.2 meters per second squared. And then we have our height, or altitude, just like that. When we solve this out, the final velocity, so 2 times 3.2 times 1200, square root to get the answer, we get 87.64 meters per second. And that is part A. We solved for that. Now it's positive because it's rising at this point. So I'm just going to replace that right there, a little gap there, that's okay. With our speed, 87.6 meters per second squared. I'm sorry, meters per second. So that's at this point right here. Now I want to know how long it takes to reach that. Well, as you might imagine, we can use pretty much any kinematic equation because we do have every single variable but time. But I like this one since we have our information. So I'm going to plug in our final velocity here, our initial, and our acceleration. Now, it's acceleration at that instant. It's not gravity. Even though gravity is acting on it, what this acceleration, it takes into account gravity, or in other words, ignore gravity for that. So when we do, we get this number. We get time is equal to 27.39 seconds, so a pretty long time. Like that. And there you go, for 30 seconds this thing is roughly accelerating. Alright, let's do part C. Part C. So now we're going to look at the maximum height. So in other words, it's asking for how high does it go? It's not a straight line. You get the idea though. We're basically looking for this extra piece here. I'll call this Y2. Well, some information we know about this section is technically if we start here, we have an initial velocity, we know the velocity at the top is going to be 0, and during this time their acceleration is now just that of gravity, implying the negative for downward, just like that. So I'm going to use this equation again because you can see we have all the information. Our initial will be the final at this point because it's going to start off with this and then go to that. So our final is 0. Well, let me write out the equation and then squared. So VF final squared equals VI initial squared plus 2AD delta Y, and we're looking for Y2. So 0, equals our 87.64 meters per second square. And this square goes through the whole thing like that. I'm just trying to be quick here. Plus 2A D. So the D becomes our variable. This is what we're solving for. Alright, so let's solve for the variable. Again, I'm skipping the algebra because I assume algebra is good. Alright, so 87.64 squared divided by 9.81. It will rise up 391.48 meters up in the air. Although I really shouldn't box it because what I need to do to find the altitude, gotta go there, is add that to the 1200. So 1200 meters plus that number. (1591.48 meters). That's the official answer here. So yeah, that's alright, I boxed it anyway. So, that's how you find the altitude or the total maximum height right there. Now what we need to find is how much time it takes to reach the maximum. So let's be efficient. So we know the time it takes to do this section, so why don't we use this section, just break it down. We'll find the time in this section and just add it to our total, this time to get the total. So whenever you can, use numbers that you have already and just break it down. So same thing, I'm going to use this equation for part D because we have all the information. Final velocity is 0. Our initial velocity is the 87 positive 0.64 meters per second. And our acceleration, negative 9.81 meters per second squared times t. Let's solve for t. So what I get is 8.93 seconds. So total to the maximum altitude would be the 27.39 plus the 8.93. There we go. And then what we get when we do that, or 39, sorry, 36.32 seconds. So that's part D, or total time. So that's the time to the altitude, or the max altitude. And then let's see, what else do we got? I think it's striking the ground, right? E is striking the ground in total time. So what we have here, we can find the strike the ground and then we'll find total time. So what I'm going to do to simplify this problem is actually start up here and then go down here. We have the height up here, remember? That's the 391. So in other words, we have the maximum altitude. So what I'm going to do is actually redraw this. So basically, here's our rocket again. And this is the maximum, which we said 1591, right? 0.48. So let's start here as our initial, because that gives us a 0 value right there. We got a delta y, max I'll call it. And then we have acceleration, gravity, the acceleration due to gravity. So even though it doesn't look like we have a lot, we can use a bunch of things. So we have an acceleration, a delta y, initial, final. There it is again. Here's this equation. Now I'm going to start here. We can choose our starting point anywhere. That's the beauty of doing some of these problems. So with that said, this is what it's going to look like. We have a 0 starting point. Now remember, a is just the acceleration, because after it's at the top, there's nothing else helping it. It's just the acceleration due to gravity. And we know how far it goes. Here we are. Gotta solve this out. Very fast, but it's falling for a long time under just gravity. 176.71 meters per second. Just to give you an idea, this is going about 395 miles per hour with no air resistance. So that's pretty crazy fast, right? There we go. Makes sense. We're really high up when it falls for like about 30 seconds. And then speaking of falling, you know, how long is it in the air? So we actually got this time already, the time up, the time to here. So really, all we need is this time right here. So that's what I'm going to do, is figure out the time it takes to fall that distance. So the equation I actually would like to use, it can technically, again, it can be anything. Why don't we do something different, although this is the one that pops into my head. We could absolutely 100% use that. That's fine. Just to be different, I'm going to use a different method. Let's use this one. Delta y is equal to VIT plus 1/2 AT squared. So delta y is my positioning. So in this case, I have fallen negative, okay, 1591.48, because I'm going down. This whole term goes to 0 because I'll start off with an initial velocity. Then I have a acceleration right here. And then there we are. Now if you notice that the negative signs will cancel, I can solve for time. So let's do that. 1591.48 divided by 0.5 divided by 9.81. Square root the answer. We get a time of 18.01 seconds to fall. So total time in air is going to be the time up here. Let me just get that number, 27:39. Plus the other time, 8.93 seconds, plus 18.01 seconds. So let's do all that. 27.39 plus 8.39 plus 18.01. We're in the air for 54.33 seconds. There we are. Okay. So we solved pretty much everything we can about this rocket. So if you have any questions, just let me know. Thanks for watching.